Okay, so here's our reaction. 79.4 grams of NH3 and 290.0 grams of CuO. And we got to figure out how much nitrogen gas is produced and how many grams there are of the remaining reactant. And we're going to use this balanced chemical equation that they gave us. Now let's remember that in the balanced chemical equation here, this means that ideally if we had 2 moles of NH3, 3 moles of CuO, and they reacted completely, we would end up with 1 mole of nitrogen gas, 3 moles of copper solid, and 3 moles of water vapor. Okay, so we're getting a lot of numbers thrown at us. So what I like to do is make a table. So here we have our reactants, and we know their masses, and we know all the reaction coefficients. What we're trying to get to is the mass of nitrogen gas here. Okay, so we have to figure out what moles of reactants we have, and then we have to figure out which one is the limited reactant, and then we can get to the mass of nitrogen gas. Okay, figure out the molecular masses. To that, you go to the periodic table, and you get the atomic masses of the components of the molecules, and you add them. So we have 1 atom of nitrogen and 3 atoms of hydrogen in a mole of ammonia molecule. So we get 17.031 grams per mole is the molecular mass of ammonia. And then you can do it similarly for the other 2 compounds. I'll just leave that on the screen for a second. Okay, so we can plug those in. All right. Now that we have the molecular masses of the ammonia and the CuO, we can basically use those as conversion factors to figure out the moles. So what we do is we take the mass and we multiply it by the molecular mass. Now, this is basically just 1 because 1 mole of ammonia is always going to equal 17.031 grams of ammonia. So when you're multiplying this, you're basically just multiplying it by 1. And then you get your moles of your ammonia and your moles of your CuO. So then plug those in here. All right, now we got to figure out which one is the limiting reactant. Now, sometimes you would have to do some math to do this, but I think we can just do this by looking at it. So we know that we need 3 moles of CuO for every 2 moles of NH3. Look at our numbers here. You can tell that this is going to be the limiting reactant because we have a lot less of this. We have a lot more of this than we would need. Okay, so we're going to assume that all of this reacts, and we can convert this number to the mass of nitrogen gas. So we take our moles of CuO and we multiply it by this using the reaction coefficients. So for every mole of nitrogen gas produced, we consumed 3 moles of CuO. So that's basically, again, multiplying by 1. And then we have the molecular mass of nitrogen. It's also basically just multiplying by 1. And we end up with the mass of nitrogen produced. Okay. So we figured that out. Now, the other thing it wants us to figure out is how much of the not limiting reactant is remaining. Okay, so we're going to assume that all of the CuO reacts again, and we're going to use a similar conversion factor here, but we're going to plug in the moles of the ammonia instead. Okay, so what this is saying is that if all of this CuO reacts, then this mass of ammonia will have reacted, 41.40. Okay. So then if we subtract that number, that mass from the mass of ammonia where there was at the beginning, we end up with 38.0 grams, which is how much ammonia is remaining.